Hello everyone, welcome to a new video. Today we are going to get into something that pretty much is going to start existing in all of your programs going forward. Technically one of these has already existed, we just didn't fully cover it. So today we are going to talk about classes and objects. So first, basically, working with the code so far, you've learned various topics like variables and like methods and even technically classes. We have used classes prior to this. So there are definitely cases where these terms are all going to go hand in hand, and that's basically what makes up Java or object-oriented programming. So variables and methods alone can't put things together. So think of it as like a sort of container of sorts where you can have all your code that does one action or one thing or works with one object all together. And these classes let us do that. So once we have a class, we can create objects that will allow us to pretty much work with different copies of that specific area or that data. So that'll make sense as we go through this lecture. So first, a class is one of the most important things in Java. As you've noticed when you are working with your program code so far, we pretty much always had a class in our code. So a class is basically just like a template or a blueprint for creating objects that you can work with. Up until this point, we technically have not created an object, which is the purpose of this lecture, but basically that's what a class is. So it's going to define the data that we can use and the actions that we can do. And that's pretty much all we've been doing so far, working with data and doing some sort of action on it. So a class can contain three things. Not saying these are the only things it can contain, but these are the most common ones that you will notice. First, we have fields, which are going to be variables that are going to store our object's data that we're creating. We also have methods, which you know because we covered that last time, but that's pretty much all actions that we're going to do on our objects. And lastly, we have something called a constructor. Now, a constructor is basically a method, but it is used for objects. So that'll make sense as we cover this lecture. So far, you have been creating a class every time you create a Java program. And pretty much that class name is always going to map out to whatever the file name is. So here is the basic syntax of a class. Generally, it will be public, class, and then a class name that you provided, and then everything else goes inside of the class. So in this case, public is our access modifier. We have class, which is going to just tell our Java program that we're creating a class, and your class name is just whatever the name that you would like to refer to that class as. So here's a snapshot of a class containing those three areas I just mentioned. So you see we have fields, which is also known as instance variables. We have constructors, and we also have instant methods. Again, this will make a little bit more sense as we go forward, but this is just kind of giving you an idea overall of what a class looks like, although we've been working with them so far. So if we were to put it into a real example, you see here we have a public class called student, and student is going to have different information in it. Now our fields are going to be the data that we're holding that deal with that class, and in this example we have name and GPA. Now, if you take a look at the constructor, it's basically set up exactly like a method because it is one, except it's creating a object, and in this case, it's creating an object called student, and that links back to the class. And inside of this method, you see we're inputting two values, which will then map out to those field variables that we created. And once that student is created, Basically, the student will then have a name and a GPA associated with it. And the last thing we have is an instant method, which is basically saying this is a method that we can use within the class to do some sort of operation. So this is an example of a class, but as we work forward, we will continue to make more advanced classes. So now that we've kind of covered what a class is, we're going to break down those class components that we've already sort of briefly reviewed. So first, let's talk about those fields. Again, a field is a variable that's going to store that object's data. So this is what you do when you declare a field or a variable inside of the class. Now, these fields are not going to be declared inside of a method or a constructor. So this basically means they should be free floating inside of the class. They should not be inside of a method. So that would be a field. And this is what we would consider our attributes or our properties of a object. So basically, what does that object have? What properties does it have? In our last example, it was name, it was a GPA. Another student can have, let's say, an ID number. Those are all properties of the student object or attributes. So you may hear attributes or properties, but it basically is the same thing. So as I just mentioned, here's an example. Our fields in this case were name and GPA. But on top of that, you could have had student ID, you could have had address, you could have had a major, you could have kept going and created more fields. But again, these are data values that are associated with that object. And in this case, our object is a student. So each student object that's created from this class will have its own name and GPA, just as you have your own classes that you attend. There are different students, and each student has their own different GPA. But a class pretty much allows us to reuse this component of code for various objects. So, technically, we've covered local variables, and now we're covering fields. But here's the difference between the two. A field is one that belongs to the object or the class itself, the whole class, while your local variable just belongs to the method that it was created in. So this is if you had a variable that was created inside of a method and not alone or free floating inside of the class. So your fields are going to persist, which means they're going to stay around as long as your code runs, while your local variables disappear as soon as that method ends. So this is why you have to know the difference and be careful when you are creating variables. If you want your variable to be around for the entirety of the code, you should create it as a field variable. If not, and you just want it for the purpose of the method, then you could create a local variable and it will basically be ignored once the method ends. So now let's get into instant methods. So instance methods are going to define an action that the object can perform. And they're pretty much going to use those fields and other data to perform that action. And in this case, they are not going to be using the static keyword. So please remember that and keep that in mind. They are not going to use static. Now, here's an example of an instance method. If you take a look, this class has one method and it's called print info. And from that method name, we can tell that we're going to be printing some info out. And in the method, we're printing the name and the GPA of the student. So basically, an instance method is allowing us to work with our fields or our data of the student class as it is pulling in those fields directly to print them out to the user. So remember I said that we're not going to use static with our instance methods, and there is a reason for that. A static method belongs to the class, but not necessarily any specific object. So that means it cannot access instant fields directly. And that's why you are not going to use it there. So, yes, you can have a static method, but it's going to be hard to work with your instance fields if you use it that way. So, let's say you were to mark a method as static, right? Basically, what happens is Java is going to disconnect the method and the object. So that basically means the method no longer knows which object fields to use. In that case, if you were to have some uh, instance variables that had the same name, such as one in a method that you created inside of your class, you could run into some issues. So once you put static, it basically severs the connection, and that's why we try to avoid using static with our instance methods. So now that we've pretty much covered that, we're going to talk about our other method of a constructor. And this is very important as this is how we can implement that object-oriented programming, because this is what helps us create a object. So a constructor is a method that helps us create our object that we're going to work with. It basically gives our object everything it needs to become a object. And it's basically going to run automatically when you create an object. So it's pretty much saying, hey, we need a new object to work with. Please create it. And these are the data points for it. So if we take a look at our example again, you see we have two fields, name and GPA. In our constructor, please note that our constructor and our class name are the exact same thing. Case sensitive as well, meaning every uppercase in the name has to also match. So in this case, you see that our constructor name and our class name are the exact same. It is taking in two values, which is string in and double G, which are going to connect back to our fields. So when we create an object, what we do is at the second screenshot where you see it says student s equals new student. When we say new, it's telling our code we are creating a new student object. That student object is going to be referred to as S. So everything that deals with a student is going to be linked with S, which is going to be a student object. And basically, S is going to be a representation for Alice, who has a 3.8 GPA. So from there, we used a class and we created an object. And again, you can create as many objects as you would like in this case. So just to reiterate what I just covered, your name for your constructor must match the class name exactly. And keep note that our constructor has no return type, not even void. So if we go back, you see it literally just says public and then it has the class name. So in this case, student. There is no void or there is no data type there. So also you can take parameters to set those field values, which you saw in the last one. We took N and G to pretty much set up our initial fields for our object. And you can overload constructors, meaning you can have different versions of the constructors that take different parameters into them. So when I mean different parameters, that means there may be a case where you want some objects to have some information and the other ones to have different information. Basically, what happens in this case is Java would choose the constructor that it needs to run based on the arguments that you're passing or the values that you're passing through that constructor. So, for example, you could have a constructor that takes in 2 arguments. You could have a constructor that takes in 4 arguments. You could have one that takes in 1. All of those are going to be their own constructor. And that is an example of, again, method overloading. But basically, they will all have different functionalities based on those inputs. So if you see this example, we have two constructors, one called student that takes in two data values, and then we have the other one that just takes in one data value. And in this case, they are technically two different constructors because the first one is allowing you to set the GPA, while the second one is giving a default GPA value. So therefore, it's not requesting that you provide a GPA. And in this case, they are technically two different constructor methods, and they do two different things. So you can do something like this where you have multiple constructors that take in different inputs. And again, your Java program will figure out which one to use based on the inputs you provide. So now that we've pretty much covered that, there is something that is very useful to you all when you're working with the code, especially when you're starting to work with your objects and your constructors. So that will be the keyword this. And yes, this has to be lowercase as you see it. So this is going to refer to the object that you're using currently to do the code. And it pretty much helps you figure out the difference between the fields that you're working with, so the fields that you created in the class, and the actual parameters that you're inputting into your constructor, for example. So if you take a look at this example, we have a constructor that takes in the name and the GPA. But remember, our instance fields, or our fields that we had in our code, actually were named name and GPA. So it can be confusing if inside of the constructor you're saying we're going to set this name to this name. When you say name equals name, you may get confused which one you're referring to. So in this case, this name is going to equal the field and name is going to equal the parameter. So when you're using the this keyword, it's basically going to connect you back to that field you created outside of the constructor or outside of that method. It's the one that can be accessed from anywhere in the code. While the name on the end is just referring to the name that is being passed into the actual data, or the data value that's being passed into our constructor. So that's the difference there. So this is very helpful if you want to use the same names for the parameters as the actual the fields outside of the class. Do you have to? No, but it is just a little bit helpful if you're trying to remember what each data point is. Along with the this keyword, we have the null keyword. And no, it can be useful. Now, do you have to have this or use this in every program? No, but this is just something that is helpful when you don't necessarily know what data value to give an object when you're creating them. So, in this case, null is not necessarily an object, it's not a string, and it's not zero. It's basically empty. It's literally just a empty space. It has no set data value to it. So basically what happens is you can, let's say, create your object. So in this example, we have a class that will be bank account, and we're saying we want to create a object for that bank account, and we're going to name it account. However, we did not create an object just yet. Basically, if you were to do something like the first screenshot, account will be null because it doesn't know what you're referring to exactly. It knows that it's connecting back to the class. It just does not know if it's an object. It doesn't know if it's going to be a string. It doesn't know what data value it has. But you could technically still do this. Now, to actually use it, you would have to create an object. And as you see in this example, we're not necessarily specifying that data type before our variable anymore because we already initialized it. We already created the variable and told it the data type it's going to have. And since we did that, now we can just create the data type because that it knows that our data type is bank account. And now we're creating our object for our bank account, which is going to be of object bank account, where we're saying new bank account and Alice checking 100. So basically, in this case, what we're doing is we're just splitting up the initialization and the creation of our objects. Do you have to do it this way? No. But I'm just letting you know that it's possible to do it this way if you need to. So when will you see null? You can see null if you have an uninitialized object or a field. You can see it if you have a local reference variable that you declared, but you didn't necessarily assign it. So like if you want to create a variable, but you're not ready to give it a value. And also with methods that have no objects being returned. So all of these cases could produce a null value. So now that we covered most of those important things about your classes and objects and even your constructors, I'm just basically going to reel it back in to connect it. So what you need to know is a constructor is going to be the object's setup method. This is where your object is created. Without your constructor, you would not have the object to work with. So it's used to prepare the object's data the moment that you want to create it. So your constructor is very, very, very important when it comes to OOP, classes, and objects. Your class is not the object itself. The constructor is the one that will create the object. The class is just the blueprint for the object to be created. It's going to describe the object and how it should be created. So that is the difference between the two. So when you're looking at creating your objects, this is just meaning that you're making a new instance or a new copy of the class to work with. And it is used by the keyword new. So you would call a constructor and build the object using that new keyword. And here's an example of that. So the very first thing you provided is the class name you're working with, followed by the variable name that you want to give that object. And then that is where you would say equals new, which is going to say, hey, we're creating a new object that is going to refer to that class name. So in this case, we're saying we're going to create a new object of whatever the class name is, and we're going to give it the expected parameters to match a constructor that you have created in the code. So basically, this is what happens when you're calling that object to be created. The new is saying, hey, we need a new spot to place this object. So it's basically giving it some memory for its storage. The constructor is going to run to set up those initial field values that you specified, and the variable is just going to give you a reference to the new object. So whatever you name that object variable. And objects are very useful because you can pretty much create as many objects as you would like from one class to constantly reuse and or have different functionalities. And again, this will make more sense as you start to use some code to work with it, but that's pretty much the idea of objects. So each call to new creates a separate object with its own data. So every time you create a new object, it is its own separate object with its own data, meaning they cannot share the same data and they are not the same object. So example of that would be if we had a student class, we can have various students. So you can have S1, S2, S3, S4, S5. You can have as many students as you would like. The main part to remember is that they are all still going to be different student objects. Yes, they both use the student class, but they are not the same student, just as you are not the same student as someone else. So in this case, you see there's two students. One's name is Alice and one's name is Bob. But they both basically can use the class how they need to, just depending on where they want to go. And the constructor is used to set the initial values. Now, once you create an object, you can use that object's data and you can run behaviors or instance methods on the object. You would do that using dot notation. So dot notation is very important when it's coming to working with your classes and your objects. Literally, it's a dot or a period. So in our first example, you see we're creating the student object of S, which S is going to hold Alice and 3.8 GPA. Now, if you take a look in our print statement, you see we have S dot name. S dot name is basically saying, hey, this object S is trying to access its instant or its field of name. So whatever field is referred to as name in this case, which in our case is Alice, then that is basically what it's asking. So it's saying, hey, can you find the field name and provide it what that name is that is associated to that object of S. Same goes for if you want to run an instance method on an object. So let's say we wanted to run that instance method of print info on our object. The first thing you would have to do is give the object name, and then you use your dot notation and then provide the method that you're trying to run on that object. So dot notation is how you can see the data values for an object and also how you can work with your behaviors of an object. So this is very important when it comes to OOP, as you will be using this pretty much after the object is created. So now to help bring it all together once more, and hopefully all of these concepts merge together and make a little bit more sense as we get into our coding tutorial. But first, what we need to realize is a class defines a blueprint for the object. So the class is saying this is how a object will be created and this is what that object can do. That's pretty much what it's saying. Now our objects are going to be created and they can combine our data, which is our fields, and our behaviors, which are our methods that we're creating in the class, to work together to do something or operate as an object. And overall, to create the objects, you use a constructor, and to use the objects, you use dot notation. So that is how all of these important points merge together to create what most people know as object-oriented programming. So we've reached the end of our lecture, and I understand that many of these topics may be confusing or maybe not, but being that it is very, 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 very foundational to Java and object-oriented programming, I would say this is one of the most important lectures that we have covered up until this point. So I do understand that it can be tricky to keep up with all of these terminologies and things of that nature, which is totally understandable. So you may have to review this a few times for it to click. But basically today what we did was we covered our classes, our instance methods, constructors, objects, and everything that goes along with these topics. So this provides the foundation you need to get into object-oriented programming and start working with your classes and objects in every program moving forward. So this is really where we're starting to pick up on our code. We've pretty much covered all of our foundations of Java. So from this point on, we're really going to start getting into some more advanced topics and allowing us to do a lot more within our code. So hopefully this was very useful to you and it makes sense. Again, after this, we will be covering our classes and objects coding tutorial where you will see a lot of this coming into play. So if it does not click, it will soon. So please just stick with me, follow along, and I will get you where you need to go. So thank you for your time, and I look forward to seeing you in the next video.